Welcome this afternoon to our KTN off-highway webinar and workshop to follow on afterwards. This is a joint event between our hydrogen economy and cross-sector battery systems innovation networks. My name is Stefan Eldred. I'll be leading you through to start with, and then my colleague Nicoletta will continue from the cross-sector battery point of view. Just very briefly to start with, how this has come about. What we have found in our both the hydrogen and the battery networks is that whenever we have an event or an activity where we mention the other group, there's a flurry of activity from people from both sides wanting to get involved in the other one. And there doesn't really seem to be anyone else joining the two up. Now, from an end user point of view, in today's webinar, that includes the agri side, construction side, and defence side. From an end user point of view, it's all about solutions to take us forward to 2050, decarbonisation, net zero, however you want to term it. And it doesn't really matter what the solution is. It could be batteries, it could be hydrogen, it could be something else. We just need those solutions. So we felt it'd be great just to have a friendly get together with people in both batteries, hydrogen, across agri, defence and construction to talk about both the challenges, opportunities for collaboration and potential solutions to drive the agenda forward. So thank you very much for joining us for that today. Okay, so just a couple of practicalities. We're obviously on a Zoom webinar here, which means that you'll all be familiar with Zoom, but within the webinar, you have a little Q&A box. So if you look on your toolbar at the bottom, you've got the regular chat function and also a Q&A box. Try and keep the Q&A box, it sounds obvious, but for questions, nice, concise questions. We will have two opportunities throughout the webinar to ask questions. And yeah, if you keep those for that, we'll make sure that we get those to the front. Therefore, keep the chat box for everything else. So networking, introducing yourselves, any technical issues or what have you, please keep that in the chat box. The webinar is being recorded. So be aware of that, and it will be available after the event, and it will be available on the KTN website. For any technical issues, Poonam is looking after us from an events point of view today in the background. So if you've got an issue with Zoom or something like that, if you direct a chat message to Poonam, then she should be able to help you. And there is this live transcript option to see subtitles, which you may or may not be familiar with. So in terms of the agenda, it looks quite jam-packed here. I won't read out every line on here, but I think the point is that after I'll introduce the innovation networks, particularly the hydrogen one, and Nicoletta will then talk about the battery side of things for us. Then we'll get into off-highway opportunities and challenges. So this is across agriculture, construction, and defence. So that's the kind of end user perspective, that what's causing challenges, where are the opportunities, and we'll then have a Q&A after that, which Simon will lead us through. And then the second half of the webinar is about pitches or just solutions providers. So these are innovative companies that hopefully have solutions to some of the challenges that we talked about earlier on. So certain people that would really like to get involved more and are probably already involved and have some great examples of how to move us towards net zero. We will then have a Q&A after that, and we will then close the webinar. Now, most of you are probably aware that we are then following that on with a workshop starting at 3:30, so a half-hour gap in between the two. And there was a separate link which came out from Poonam for the workshop. So the workshop will be much more hands-on. It'll be a smaller number of people. We will have a little bit from APC and KTN-iX, but then really the bulk of it is about those breakout discussions, and we'll be looking at what are the challenges, what are the collaboration opportunities, and where are solutions really needed. So please do join us if you can for that, and if you're already registered, please do hang around. Don't forget to come back at 3:30. Thank you. Okay, so just quickly on KTN, I'll try not to do a big sales pitch. Most of you on here are probably quite familiar with us, but basically we are we're all about connecting innovators and partners. We exist for that. We exist to help seek out new opportunities beyond existing thinking. And I think the key thing for me is that real world solutions. So we are not and do not want to be a talking shop. We want to, hopefully you'll see if you can stay for the workshop later on, we want to try and drive these conversations to real world solutions that we can help to facilitate and drive things forwards. Okay. The idea is very much about connecting innovators with new partners, those new opportunities we talked about, to develop their existing thinking, and accelerating these ideas in the real world. So I think, again, that's the key thing, is about making things a reality and moving them forwards. So who are we? There's about 200 of us dotted across the country. And the bottom line is, if one of us isn't an expert in your sector or doesn't have an answer for you, then somebody else will. Anything from, well, we've got agri-food, transport, materials, chemistry, and clean energy and infrastructure represented today. But we could go a lot further into agri-food, defense, of course, related to, we could go much further into biomedical materials or space, you name it, we've got people involved in that sector. And just in terms of what that actually looks like in practice, because there's a lot of talk, but how it looks is it's about connecting, funding, influencing, supporting, and helping people to navigate. I think often the navigating bit, UKRI and government support can often be quite convoluted, so we can definitely help people to navigate that. We definitely help connect people in the first place, whether that's in terms of competitions and funding available, and hopefully we can have a little bit of influence to strategy. So the hydrogen economy innovation network. So this exists to help enable, the key word here is uptake. So we're trying to validate views on current challenges and help enable local clean hydrogen uptake at scale and cost. The reason I highlight the word uptake is there's lots of discussion around clean and green hydrogen production, and we're not saying we're not keeping abreast of that and want to be involved in that, but where we see a big opportunity is making sure that end users, end sectors have understand how to use the stuff. So it's great producing it, but we need to make sure we've got a use for it and we can move that forwards. What that looks like is, in the background at the moment, we're working on a UK capability map, a kind of resume of the UK's strengths and weaknesses to help people who are new into this area, new emerging sectors and markets. The challenge, bit like we're doing today really, but to provide a validated viewpoint on the challenges that are holding back deployment in some areas. And then out of the challenge identification, we're then looking to the how do we help find solutions? And we have got something called Innovation Exchange, which we'll talk about later on. I'm conscious that I'm already running over time. So in terms of why sign up, there is a link at the bottom, but if you go on the KTN website and search for hydrogen, you'll find it. There's over 1,500 people involved at the moment, and basically we will try and keep you abreast of what's happening across the UK, whether that's through monthly newsletters, mail shots, or getting involved in some of our capability activities. I won't talk about all of these, but we've had great success already with pre-launches and launches. We tend to find there's several hundred people want to get involved whatever event we run. We also have close links, as do the battery groups, with Canada and North America. So we're trying to make sure that we utilize those links for the good of both sides of the pond. Okay, and the next step, so we've got this workshop today. We are looking at a similar workshop in the glass sector, and we're hoping that out of today we will we'll have some gaps which require solutions, and we can try and help find those solutions for you in conjunction with colleagues. Okay, Nicoletta, I'm going to hand over to you.
Thank you very much, Steph. Excellent introduction. I'm Nicoletta Piperidou from the Clean Energy and Infrastructure team at KTN, working alongside Steph. I'm leading on a sister network to the one that Steph is running. So this is the Cross-Sector Battery Systems Innovation Network. This is a community part funded by KTN and part funded by the Faraday Battery Challenge. And it aims to open new markets for the battery industry, promote innovation in batteries, and help decarbonize a wide range of end users. So as you can see in the next slide, we've started from a diverse but small group, looking at defense, aerospace, rail, a few specialists. So that activity started a couple of years ago. We were meeting on a quarterly basis, exploring areas of interest, and subsequently we've grown to something much bigger. So in the next slide, you can see the new online platform that we've recently launched. This is an online hub where you can find the latest news, events, resources, and it also includes a networking hub and a battery systems landscape map. So in the next slide, you can see this is the landing page for the landscape map, and it gives you a few options to look at organization, supply chain interests, and sector interests. This is free and accessible for all, so you can just go to ukbatteriesnetwork.org and access the landscape map. And if your organization is not there, you can just click on the sign up button, submit your details, and we will make sure that your organization is featured there. So in the next slide, you can see just a quick overview of how it looks. So this is, if you click on the organizations overview, over 250 organizations are currently represented on the map, and there's scope to include many, many more. So if your organization is not featured, please do sign up and become part of the community. And in the next slide, you can see the networking hub area of the hub, where you can submit your challenges and solutions, and other members can request an introduction. So again, this is a very useful feature that you may wish to use. On the next slide, yes, just again, our contact details. We'd love to hear from all of you. And just to say that please do not be shy, use the chat box and tell us who you are, where you're joining us from. We'd love to hear from all of you. So please do write in the chat box. We would love to hear from all of you. So thank you very much for that. And I would like now to invite our first speaker, Shamal.
Thank you very much. Good afternoon, everyone. My name is Shamal Mohammed. I'm a Chief Technical Officer at Agri-EPI Center. We are one of the agri-tech centers in the UK. And for today, what I would like to do is just give you a bit of background about some of the key challenges facing the industry, and where the green solutions can help the food production system to go forward and achieve the net zero carbon goal as well. Next slide, please. So just a bit of context in terms of food production and the food security. We obviously have a climate change, and we have a fast growing population as the two key factors that affecting producing sufficient food for the fast growing population in the future. Obviously, we have two options. Either we can expand our agricultural land, which has a negative impact on biodiversity and deforestation, as an example. In the same time, we need to find more land to grow trees and other crops for storing carbons in the soil. So there is a competition here, and also there is a bit of a negative impact. If you increase in the farmland, it have a negative impact on the productivity itself as well. But also the next option in feeding the population is intensification of the existing agriculture land as well. And this one also have a negative impact, which is soil degradation and greenhouse gas emission is the two key ones, which also have a negative impact on food production system as well. So we kind of in a dilemma and in a loop that in one hand we need to increase productivity, in the same hand we have to increase our environmental sustainability. Next slide, please. This is just to show you some of the areas where the greenhouse gas emission happening throughout the food supply chain is not only on the farm level, but also in terms of the processing and transporting and sort of a consumer level as well. So there are multiple areas where the green energy can play a role to minimize the upward sort of arrow, if you like, and we in agriculture working on some other technologies in order to store and sink most of the carbons back into the soil and helping achieving our climatic goal as well. Next slide, please. I would like to kind of focus on 3 areas, which is really an important one for food production system, and also there is a huge role for the hydrogen power energy to play achieving our climate target as well. So first one is the production of fertilizer. As you know, this is hugely important and contributing massively into the greenhouse gas emission from agricultural productivity. I believe about 40% of greenhouse gas emission is basically from the production of fertilizer. And there are some companies, they already started looking at using hydrogen power to create and to produce fertilizer. And I think this is one of the areas where the green energy can play a huge role and helping the industry to move forward in terms of the sustainability as well as a reduction of greenhouse gas emission. The second and obvious one is the tractor. Again, there are companies working in these areas. For example, John Deere working on some electric cars and tractors, and also trying to bring the more autonomous tractors into the industry as well. The third part is in the food processing. Very recently, the government launched a grant funding for whiskey distillery in the Scotland as well as in England to use the hydrogen power for the process of whiskey production. So I think what I wanted to make the point here is these 3 areas is the key for utilization of this new energy and green energy to help the industries moving forward and minimizing the greenhouse gas emissions. Next slide, please. So what I thought it would be useful for the audience here, just to give you a bit of introduction about Agri-EPI and how we can help. As I mentioned, we are one of the 4 agri-tech centers in the UK. We are mostly focused on technology application, and our role is to bridge between the science and the industry. Next slide, please. So we have 4 main key areas of activities. So agri-robotics and engineering, which is more working with machinery and machinery industry, but also some of the novel solutions is coming to agriculture, like robotic systems and automation that can play a huge important role in minimizing the input, but also maximizing the productivity as well. The second area is more around crop technology. We do a lot of work on precision livestock and dairy sector, but we also have a network of farmers to look at the roles and the importance of precision farming data. Next slide, please. We base in 4 different locations across the UK. I'm based at Cranfield University. We have an office and a new building at HYPERDRIVE University in Midland. We also have a facility in Scotland in collaboration with our key academic partners, SIUC and Edinburgh University. In southwest of England, we have a collaboration with Kingsay, which is an autonomous, sort of a heavily automated dairy system, looking at robotic and automation applications in the dairy production. But also our ambition is to make our dairy farm as an exemplar for achieving net zero carbon, but also working with the wider industry to kind of bring this sort of a novel solutions into the industry to help the sustainability of our food production systems. Next slide, please. This is our Southwest dairy. As I mentioned, we have a automated feeding system, a robotic milking machine. Most of the cows, they have a multiple sensor technologies. We are thinking about bringing some sort of AD plant to utilize the output of cows into energy production, but also looking at some options. Maybe hydrogen as well as batteries can help in some of minimizing the energy usage in a supply chain as well. And we're working with a large number of companies in dairy sector and other sectors as well. Next slide, please. One of the unique sort of assets and resources we have is 24 farmers across the UK commercial farm. We invested in technologies and sensors, and the main objective of this network is to use the farms as a validation and a platform for assessing and developing new technologies. And they all have various different sensor technologies as well as data collection in order to help companies as well as universities to look at novel solutions in the industry, but also do a lot of knowledge transfer, engaging with the farmers and the farming community as well. Next slide, please. We also work with a large number of companies. We created a sort of an ecosystem for innovation. We have more than 175 members, and it is growing as well. And then the whole purpose of that is to kind of bring the right partners into right projects and collaboration in order to build our solutions and helping the industry moving forward. Next slide, please. The kind of service we provide, collaboration and building partnership obviously is one of them. We also help with the scope funding opportunity, project management, and then using our network as a launchpad for new technology and new startup as well. We also have international activities and then bringing UK agri-tech solutions into an international market, but also helping with the R&D and the technical aspect as well. So there are variety of activities. We work with our partners and our members and helping them building these new solutions in agri-tech sector. Next slide, please. Our international work, so we have a smart farm project in China. It's been going on for a few years now. It's a 4-phase project. It's a collaboration between the UK and Chinese government, and this is something has been a successful story for bringing the UK technologies and demonstrated in a global market. We also have a project and a smart farm in New Zealand. We have a demonstration farm in Paraguay where we demonstrated the solutions from multiple companies from the UK and helping exploring an international market for them as well. So that's probably it from me. I'm happy to take any questions later on. Thank you.
That's great. Thank you very much, Shamal. Very informative. So now I'm going to hand over to, I think, Andrea, who's going to lead us through some of the construction challenges. Hi, Andrea.
Hi, Stefan. It's me first, Neil.
Oh, I beg your pardon. Hello, Neil. There we go. Okay. Hello, Neil.
Good afternoon, all. Yeah, good afternoon, all. So I'm Neil Waite. I'm the head of Environmental Sciences at HS2, and we've got some colleagues on the call to go through this section. Andrea Davison, our air quality lead, and we've got some representatives from our supply chain as well. We've got Bikia Andrews from Balfour Beatty and Robert Lockwood from SCS Railways. So hopefully you should all know HS2 is the new railway in the UK, first railway to be built for over 100 years. And we're currently split into 3 phases. So London to Birmingham is phase 1, and we're at the main work stage of that. You may have seen the tunnel boring machine being launched a couple of weeks ago. Phase 2A, Birmingham to Crewe, gained permission earlier this year, and we're preparing for some early works on that. And then Crewe to Manchester, phase 2B, we're about to put the planning application in, effectively the hybrid bill submission to Parliament at the end of this year. So what are the challenges in this space for HS2? Well, we're all in the same boat, of course. We're all working towards net zero 2050. So we see this, the construction phase of HS2 as being a great opportunity to be a leader in this space. The commitments we make form part of the acts that gives us permission to build and operate the railway, and they're all fed into our objectives and policy. We've set very tight emission standards for all construction vehicles and equipment, and we've set a 50% reduction carbon reduction target for all our contractors. So that's using a sort of normal construction baseline of carbon use. So they need to minimise that by half over the term of their build period. So the solutions for HS2, as I say, is a great opportunity for us to work collaboratively and innovate with a series of partners, being the biggest construction project in the UK. You can see on the slide there some of the companies and academia and some of the bodies we work with, and it's really about having a whole range of innovations over a series of aspects of construction. But one of our priorities is to move away from the dependency of diesel in construction. So really looking at our plant and equipment and vehicles, getting them away from diesel into sort of hydrogen and electric. So I'll now pass over to Rob Lockwood, who's going to talk about some of the things he's been doing on the ground.
Hi there, my name's Rob Lockwood, and I work on the SCS railways, and we're currently in the early stages of construction of the HS2 railway. I had the benefit of also working on the enabling works, which was essentially a very large sort of like demolition of a large swathe of sites within the London area, and it's now the sort of like a real benefit of working on something where we're actually building something instead. But it just gives you a bit of context there that, you know, from demolition all the way through to construction, we've tried every sort of opportunity we can to try and reduce our reliance on diesel, reduce our carbon impact, but also reduce our emissions of particulate matters and nitrogen dioxide as well. And hydrogen and battery operation is also an ideal opportunity to try and reduce our noise emissions from construction sites as well. And we've taken the opportunity, we took the opportunity very early to trial a hydrogen electric van to varying degrees of success. Back in 2017, 2018, the electric vans have flourished since then, but not so much on the hydrogen or hydrogen electric hybrid. We've also took the opportunity to try smaller hydrogen generators. There is a lot of sites that we have. We have huge sites in the middle of London, and then we have massive sites out in the edge of London, but we also have small satellite sites as well. So we're always looking for power opportunities that don't just rely on the diesel generators. And these small hydrogen generators for equipment and for my purposes here on air quality and noise monitors, been absolutely ideal to trial the smaller sort of opportunities where hydrogen kicks in nicely, just to replace the small generators that are petrol or diesel. One of the mainstays that we have on all of our sites now, we work into the late hours of the day, and floodlighting is always a necessity. And this has been an absolute sort of mainstay now, floodlighting of our sites using hydrogen powered fuel cells. Hopefully, you know, we'll see this more and more and more widespread use, trying to get rid of the actual diesel generators. Now we've got other hybrid and electric opportunities there, where we've tried hybrid excavators. Early on, we had the first hybrid excavator back in 2017, and now we've expanded that into more than 20 across our whole project there. One of the mainstays on our sites is power generation, and that is through the use of hybrid generators backing up a diesel generator. I wish it was backing up something else like a hydrogen generator as well. There is also lots of machinery that we have on site. At the current stages, it's only around the small electric and battery machinery, so small excavators, dumpers and telehandlers. But we are moving into larger opportunities whereby we're trying to use renewable energy, battery backed up by wind and solar technology, and also larger scale hydrogen opportunities for major welfare compounds rather than the small isolated ones that we have. And I'll hand over to Bakir.
Thank you, Rob. much appreciated. So I'll just take the next couple of minutes to delve into some further examples of what can be achieved in terms of carbon reductions. So here you can see the evolution of tower lights. What you can see is that the VT1, which was like the workhorse of construction up to 5 years ago or so, was using about 2 litres per hour of fuel. And we've been able to bring that down to about 0.27 litres. So that's an 86% reduction, just demonstrating the art of the possible. But now we can even run completely solar units, and we've used solar maps to map the country of where we can deploy these all year round and where we can't, and where we have to use hybrids. But how's this all possible? Well, you know, one, by moving over the actual lighting fixtures from metal halide to LED, but then two, advances of battery technology, advances in solar power, but also crucially in controls technology that goes with these units. So you can dim them, you can remote control them, and so forth. Next slide, please. So very similarly, Bob touched on this, but getting power to sites is a real issue. Now, if we want to use electric equipment on our sites and have zero emissions, we need to ensure that we've got a clean source of power to power them. So there's no point having electric excavators if you're going to be powering them with diesel generators. So here we've got a new ProPower unit, the first one in the country to be trialled, powering 3 JCB electric mini diggers. And so we were able to run this unit 78% of the time without any diesel at all. So really, really useful. You've got solar panels powering up the battery powering up the mini diggers, and then just occasionally having to use diesel fuel. Next slide, please. So another sort of innovation that we've been working on, and mainly within visible systems and sensor low emission construction and Sunbelt rentals and HS2, is EcoNet. So we developed the system with which is demand side energy management system, which really controls your transient loads and can reduce these by about 30%. So for your site compounds, you could get away with a much smaller power supply than you need, which means that you need less fuel or a smaller power connection, which is a lot cheaper to get and a lot easier to get. And what we're now doing, the technology was really developed in partnership with Invisible Systems and Sunbelt, but what we're now doing with HS2 and CLEC is to measure the air quality benefits of this solution. We've already, I mean, it's taken us 3 years to develop this, but we've already deployed it across 40 sites, over 40 sites, I should say, in the UK, and we're continuing to roll this out. I mean, it's been really, really successful. And it's very clever, you know, for instance, if you've got transient loads, such as like someone's having a shower, and your peak demand goes up, this then will switch off a radiator for the power of that the shower's on. No one will notice that that radiator's off for that time, so you're getting away with a small connection. Next slide, please. So another thing that we've been trying to get to grips to is obviously hydrogen, like everyone else. And again, we're working in partnership with Ulemco and HS2 and the Centre for Low Emission Construction. And what we're doing is to retrofit, we're going to retrofit 3 HGVs that will then be dual fuel vehicles, so both on diesel and hydrogen, just so that we can get our arms around the technology, understand it, use it, get rid of some of the misconceptions around it, but also really give it a good go. And I mean, hydrogen is absolutely vital to all of our decarbonisation strategies. So, and as part of that, we'll be measuring all the emissions, so the particulate mass, the NOx emissions, the total hydrocarbons, carbon monoxide, and so forth. Next slide, please. Oh, sorry. Just to mention, as part of that, we're also HS2 also investing heavily in developing a business case at the moment to invest heavily in the associated green hydrogen infrastructure that will be required to do this. So ultimately, in the long run, what we're looking to do is move from diesel-powered kit to either electric kit or hydrogen powered kit. Now, to get to net zero, obviously you can already get electric powered equipment for smaller sized plant at the moment, but what you really can't do is get medium size or large size equipment, except for a few exceptions. And for hydrogen, there's very little out there on the medium and large scale either. So in the interim, what we'll need to do is use hybrid solutions. Obviously, there's a whole piece around the efficiency side, and I showed some examples there, but there's a lot more out there that's being done. But there are loads of challenges. I won't have time to read through all of these now, but obviously the hydrogen network to support this is absolutely key, and it's a bit of a chicken and egg situation at the moment with the OEMs. No one really wanting to invest too much in hydrogen technology until the infrastructure is available and ready. We also need to ensure that that's available throughout the country, because with range anxiety, where do you fill up? So where can you deploy that plant? All of these things need to be sorted. Space and storage limitations, especially for inner city sites, can be an issue, and so forth. Another big area that really needs some support is ensuring that we've got green hydrogen supply. 95% of the hydrogen available at the moment is grey, and we also need good data, so we need conversion factors to support us with all of this. There needs to be more battery and hydrogen technology, machinery out there. I mean, great strides have been made in the last 2 years, but we need to see a lot more of that, especially for hydrogen on the medium-sized generator plant. That's really crucial. There are really good solutions for the bigger plant, but we need medium-sized solutions now. And then, I mean, I'm sure that this will improve with time, but there's sort of limited battery capability. Costs continue to drop at the moment, and storage seems to be getting better and better, but it still needs to improve, and cost and commercials are obviously key. And obviously people are also reluctant in many cases to be the first mover. So that's why these innovation projects that are funded by HS2 are so important to demonstrate the art of the possible. Thank you, that's me.
Thanks, Bakir. You took the words out of my mouth in the end. So Stefan, let's go back to you, and let's go through defence and then jump into Q&A at the end.
Exactly right. Yeah, thanks all. Thank you, Alpha, SCS and HS2. As you can see on the screen now, we're just going to go across to Darren from DSTL. Hi, Darren.
Hi, yeah, good afternoon, everybody. Yeah, I'm Darren Browning from the Defence Science and Technology Laboratory, part of MOD. I'd like to take just a few minutes to discuss some of the challenges facing greater electrification of defence, and hopefully how some of these may overlap with the off-highway market. Next slide, please. So MOD sees net zero and sustainability is an important issue. I guess as evidenced by the recently published strategy shown here. Obviously can't give too many details in a short talk, but the highlights are covered by two main themes. Firstly, the need for us to adapt to climate change world, and secondly, to reduce our emissions in line with government targets. And as for the technology to do this, it's identified that in most cases, MOD needs to be a fast follower of civilian technology, and therefore we need to engage with civilian research and industry on this issue. Next slide, please. So electrification is one of the ways to help achieve net zero, and it's expected that the future battlefield is going to become increasingly electrified. This will benefit emissions if done correctly, but also bring other capability benefits, such as reducing signatures by using quiet batteries rather than hot, noisy engines. In addition, many future capabilities and increased digitalization will require more electrical energy. It's perhaps obvious that technologies such as lasers, etc., will require more electrical energy, but perhaps less obvious that increased data processing and transmission will also increase the electrical energy needs on the battlefield, especially since there's not mobile cell towers conveniently located. It's worth noting that Army is now writing its battlefield electrification strategy in consultation with industry. And as early steps into this space is building a number of hybrid electric vehicle demonstrators and the project TD6, including a manned truck and a Foxhound and Jackal fighting vehicles. And I'll show some images later. And it's also important to note that electrification of batteries aren't only part of the solution, and future fuels such as hydrogen and others are also important. It's not clear yet to us anyway what the future fuel will be. And in fact, General Nugi knows that we're entering a decade of fuel or energy transition. Next slide, please. So here are some images of the TD6 hybrid vehicles I mentioned. You've got the MAN SV truck at the top, Foxhound on the left, and Jackal on the right. And a key point is that these are demonstrators using different architectures to allow mod to better understand the pros and cons of electrification and set its future requirements. So they're not optimized or final solutions yet. So in terms of requirements, we see hybridization as the medium-term solution to improve fuel efficiency and reduce fuel use. It's too difficult yet to fully electrify a main battle tank or armored fighting vehicle, since batteries still can't match the energy density of diesel. However, smaller vehicles could be fully electric, including unmanned support platforms such as unmanned ground vehicles, unmanned aerial vehicles, and unmanned underwater vehicles. And these could perhaps be battery or fuel cell powered. Some of the requirements for an armored fighting vehicle would be to provide silent watch. That's meeting the auxiliary loads with the battery, the main engine off. Perhaps silent approach with the battery meeting the full platform needs, but for a shorter range and shorter period of time. And also exportable power, for example, to recharge soldier batteries and potentially recharge other platforms. Next slide, please. And so for battery requirements, in most cases, mod plans to fast follow the civilian developments, given the huge commercial investment into electric vehicles. However, we may need to adapt commercial batteries to meet military needs, such as harsher temperature and tolerance to greater levels of abuse. It's worth noting that some specialist batteries will still be needed that aren't being addressed by civilian markets. This is especially, I guess, the case for high-energy primary batteries. In terms of performance metrics, everyone wants a high-energy, high-power battery that weighs and costs next to nothing. And I've listed the targets from the government's Faraday Challenge at the top of the slide. And these broadly also align with mod's needs. However, batteries, like most things in life, are a compromise. And it's noted that those Faraday targets cannot be achieved in a single battery. And this is perhaps where mod may differ from mainstream civilian batteries, that we may make different trades and compromises. The spider diagram at the bottom of the slide shows various battery metrics. And these may be rated differently, say for a COTS electric vehicle or military hybrid electric vehicle, with perhaps power, performance, and safety ranking higher than cost and cycle life for a military platform. It's also worth noting that chemistry is very important for batteries, but so are the wider materials and system issues, including things such as conductors, separators, packaging, safety systems, and heating and cooling systems. And these can sometimes amount to up to about half of the battery system's mass. Next slide, please. So for detailed requirements, mod tends to follow defense standards and sometimes adopts US military standards. And two of the important ones are DEF Stand 0035 and MIL Stand 810. And these list a range of environmental conditions equipment must survive, including temperature extremes and shock and vibration. It's worth noting that these list a wide range of conditions, severities, and tests, and not all are applied to all equipment. And therefore, seeing kit listed as maybe 810 compliant is a bit meaningless if the tests and severities themselves are not captured. As an example, typical vehicle requirements are to survive storage from perhaps -54 to +88 degrees centigrade, and operation from -46 to +70. And any battery would be expected to do the same. However, some platforms do allow power derating at extremes of temperature. And there are also a range of different shock and vibration profiles listed for track and wheeled vehicles, and also electromagnetic compatibility is very important. Next slide, please. I think there's some ideas for how we could learn from civilian off-highway vehicles. There are perhaps some similarities in that the military also buys limited numbers of platforms, far less than commercial electric cars. It's therefore expensive to develop a new battery for each platforms, so we're exploring whether a modular battery can be used. For example, can we use the same battery modules for different platforms, using less or more of them as required? And this should reduce costs, improve logistics, and simplify upgrades. Hence, we're very keen on standardization. So I wanted to reach out really and ask if there are any standard modules from industry we could perhaps use or learn from. And also wondered whether there's any standardization emerging between off-highway platforms, ideally across the industry. Another strategy we're investigating is whether we can standardize with partner nations, such as the US, or ideally across the whole of NATO. And this could also perhaps work the other way around. If the military standardizes on common battery modules, could the civilian off-road community perhaps adopt these? We've already standardized on a common starter battery and the old lead acid 6T, and lithium-ion variants of this are now emerging. Next slide, please. And so to conclude, mod is going to be increasing electrification, and we'll have greater need for batteries and other electrical storage and generation systems, and are keen to fast follow civilian developments where possible. And this could be at the cell or module level or even other systems. Thank you very much for your attention. I'm happy to answer any questions later or perhaps offline.
Great, thanks Darren, and thank you Shamal, Andrea, Neil, Robert and Bakir. We're running a few minutes over, but I think we've still got time for a few questions. Simon, have we got some good ones coming through?
Yeah, so thanks very much, Steph, thanks very much for everyone presenting there. Some really interesting presentations. If I can ask everyone who presented to please switch your camera on, as when you're answering a question, it'd be great if the our guests can see you speaking. So first question, and this is for Shamal, about the Agri-EPI. Have you had any interest from your members, or how much interest have you had about decarbonisation of vehicles? Is this a question you're getting asked every day, or is it less frequent than that?
Well, obviously there is an interest, but I think, you know, if you look at the greenhouse gas emission in agriculture, the tractor or the machinery in general, it has probably a smaller sort of impact on the total greenhouse gas emission. Having said that, the whole issues around battery and its application in robotic solution, it make a lot of interest from the industry. So having some sort of a long-term solution for these robotic systems is more applicable. As I mentioned, you know, there are companies working on electric tractors and autonomous tractors. Obviously, there is huge interest from both sides of reducing greenhouse gas emission, but also, you know, increasing our carbon storage in our soil. So I think, to answer the question, yes, there is, but probably in my view, in a more smaller systems, the battery solutions has more potential.
Okay, thank you very much for that. So next, this is for the HS2 team. It's a rather long question, so just bear with me. So given the extensive linear nature of your project, you must be gathering a lot of data on supply chains and environmental data, so air quality and solar radiation, neighbouring impact, etc., covering a big swathe of the country. Will you be making this data available to other non-competitive users? And if yes, how? And I think this is a very important point, because it's about sharing data for the greater good of it. So could someone from the HS2 answer that, please?
So you get off mute first, but it was me. So hi everyone, I'm the air quality lead on HS2. Just taking one step back, I saw there were a few other comments, if you don't mind me just popping up on a few of those as well, Simon, is there's lots of different solutions in the market. And as a project, as that question has noted, we've obviously got the far reach across the country, which is this opportunity to springboard ideas into the market, to take an idea from concept right the way through and implement it on the ground as sort of the new norm. So we do have an innovation team at HS2, and some of the innovations that Rob and Bakir both spoke to, we're very big on trying to push those through the market and make them the norm in construction. And then, of course, across other sectors. It was interesting to see fully electric tractors as well, to see how we could maybe feed in from some of the learnings from the agriculture side into construction as well. In terms of air quality data across the route, we do various types of monitoring, and all of that is published online and is freely accessible from the gov.uk website. And as we move further up the country, there will be obviously more lessons learned. We've got a Learning Legacy website, which will be up now during the summer, and more information around that will be shared there publicly for anyone to download. But it's really good to see some of the good ideas coming through and the different types of technology coming through. I saw Volvo's and Caterpillar and a few others that I've seen. And sort of in the next session, you'll hear more about some of the others being tried on HS2. I mean, of course, continue to share that within the industry so that we can share those lessons learned across sector. As soon as I finish talking, I'll pop a few links in the chat of where you can find that information as well.
Thank you very much for that. So final question before we go to the next session, and this is for you, Darren. So it's rather specific, saying this company, Chris Horton, has already done some Innovate backed work for e-hubs and electrification, and they've seen the wider calls, but are there any other specific ways to engage with yourself?
So I guess always happy to have information. So looking at that specific question, I think if you want to drop me some details, I'm not the expert in that particular area, but I have a couple of colleagues who are, and we're still obviously looking at electric drive. So yes, please send me some information, and I'll find the right colleague in DSTL to get back to you. Also in terms of wider ways of engaging with MOD, obviously you can contact DSTL directly, find an expert, but also there's something called the Defence and Security Accelerator that looks to try to take proposals up the TRL chain where they've got particular defence impact. And if you just search for DASA or Defence and Security Accelerator and Gov on Google, it should pop up as the first link. So that's perhaps 2 easy ways to engage in with MOD. I know MOD is a many-headed beast, so trying to find the right person can be quite difficult, but usually you find somebody, they'll pass you on to somebody else, and you eventually get to the right person.
Thank you very much. And the other way you can engage as well is you can speak to us at the KTN, because this is a cross-sector workshop that we're doing here, across where there are similarities between defence, agri and construction. So you can speak to us and we might have some thoughts about where your idea could input as well.
Yeah, very good point, thanks.
So thank you very much for that. So I'll pass you over to Nicoletta now, please.
Thank you very much, Simon. An excellent presentation so far. So now we're moving to a different part of the agenda where we will be hearing from innovators on what they are actually doing to address some of these challenges. So firstly, I would like to invite Richard Kemp-Harper of Arcola Energy. Richard, over to you.
Thank you very much, Nicoletta, and good afternoon, everybody. So I'm Richard Kemp-Harper, Strategy Director at Arcola Energy, and Arcola Energy is a specialist in zero-emission vehicles. We do vehicle integration of complete powertrain systems and act as a vehicle manufacturer and OEM supplying complete vehicles to customers. We specialize in hydrogen fuel cell powertrain systems. We've been working in that for 10 years, and we're the leading business in the UK in developing these powertrain systems for particularly heavy vehicles. As has already been mentioned, heavy vehicles, particularly heavy duty, where you've got a hard, aggressive duty cycle, really suits hydrogen fuel cells as a technology as opposed to batteries, because you can carry more energy on board the vehicle as hydrogen, at least by weight, and you can refuel more quickly. So for vehicles that are busy and working hard, then hydrogen fuel cells is a really good option. We've been doing projects in buses, I'll show you a bit more in terms of refuse collection vehicles and trucks and trains as well, and lots of options on that. So next slide, please. What we have developed over the last 10 years is a flexible platform we call our A-Drive, which just has the various components of a fuel cell and hydrogen powertrain that can be adapted and suited then to any vehicle. So yes, it includes the hydrogen fuel cell tanks and turning those into a safe and compliant energy storage system. You've got the fuel cell system, which turns that hydrogen into electrical energy. And then you link that with high power batteries to provide the traction energy through your electric motor to the wheels or hydraulic systems. So the way we think of how the technology works is that your hydrogen and the fuel cell provide your energy store, so storing lots of energy on board a vehicle, and then the batteries provide the power delivery. So it's a small battery, but running at high power so that you can, particularly for heavy duty equipment, you've got that power delivery you need to get the grunt to do the job. So we've got that platform available and adaptable for many vehicle types. Next slide, please. One of the ones we're bringing to market at the moment is a refuse collection vehicle product. It's got roughly double a daily duty cycle of energy on board. So you can see the sort of level of energy storage you can get on a vehicle. You don't lose any payload weight because hydrogen storage is light compared to batteries, and you don't get battery fade at the end of a shift because you're delivering power with that small battery all the way through. So that's a really good example of a product. But if I can go to the next slide, what we've got is the option with our platform to adapt that to more or less any heavy vehicle. We've done buses, we've done work in trucks and trains, we have indeed done an off-highway vehicle prototype, which included converting the hydraulics to run off an electric drive instead of off an engine takeoff. And we've got a train conversion project underway in Scotland at the moment. So in essence, the offer is this is a technology platform that's available to adapt to any vehicle. Also bear in mind that because we've got an electric generator and a fuel cell on board, that every vehicle is also a mobile generator platform. So with a simple, almost trivial adaptation you can have a three-phase or other appropriate supply off a vehicle, and you've got a zero-emission generator from your vehicle as well for power takeoff and equipment or whatever. So yeah, any vehicle is possible. The challenge, and this is one to throw back to the end users here, if you like, is that which vehicle do we pick? Every vehicle integration has its own cost of development. This is why you're not seeing many being developed for this sector or these different sectors, because actually you've probably got one of several different vehicle types in agriculture and similar in construction. How many vehicles can we do of one type so it's affordable to do the integration and development of the vehicle to make it work? So finding that first platform, finding the real requirements and the vehicle types which are suitable and adaptable to put different bodies on, perhaps. That's the challenge, I guess, throwing back to you that we perhaps discuss in the workshop this afternoon. So next slide then is just my details, and that's all from me, and hopefully hand on to the next person.
Thank you very much, Richard. That was excellent. I would like now to welcome Steve Abbott of HYPERDRIVE Innovation. Over to you, Steve.
Yeah, hello. Thank you. Okay, so I've only got a couple of slides, so I'll be quite quick. HYPERDRIVE Innovation. So we're based in Sunderland in the northeast of England. I've checked and we're not on the KTN map, so that's a job for me after this. We were set up nearly 10 years ago now. We started off as a consultancy looking at a kind of niche electrification project. So small marine applications, small automotive, through a number of Innovate UK projects. We then, through the help of the APC, we started to develop our own products, so our own standard battery pack. And some of the applications you see in the photos there use our standard modular lithium-ion NMC battery pack. Our key markets, certainly to date, very much off-highway vehicles. So that includes materials handling. So whether that's kind of warehouse robots or the forklift truck you see there, which is for cargo tech. So specifically, we've tended to start quite small with machines. I think probably concurring with what Richard said there, there's got to be a business case, there's got to be value. Batteries are expensive. So the reason for using our batteries is you can get a lot of energy density in there and a reasonable degree of power. So that can power the kind of equipment you see there. Obviously, JCB are a key customer. We've also started working with a few British companies over the last year or so, which is quite interesting. So that picture there of the Dennis mower is interesting. And also the European marketplace is interesting, especially in construction, lots of legislation coming in. So that particular kind of green, larger excavator is a company who are an aftermarket converter of brand new Volvo machines. And they're looking at machines up to 9 tons. And because of the legislation in the Netherlands and the subsidies, that's working for them. So they maybe next year, well, over this year, we'll make probably about 50 of those machines. We are kind of fortunate to be in a growing market. There's lots of growth. It's about choosing the right opportunities. We're about 70 people. We doubled turnover in the last year, which is amazing with everything that's happened. And we're hoping to grow, keep growing at a similar kind of rate. Probably the next slide. Thank you. We, as well as some kind of key customer projects, we've got a particularly interesting project underway with Hitachi Rail. So that's big batteries for fully electric trains. So that's probably halfway through in terms of development. In terms of our main product range, our modular pack range, we are looking at those challenges which are on there, which is all about battery value, battery life, bigger batteries, handling extreme temperatures, optimizing the system, first life, second life, and then integration. And importantly, we are, specifically for this webinar, we have recently done a prototype with a different type of cell chemistry, which is a much higher power cell chemistry, so is much more suited to hybrid systems like hydrogen systems. So we are looking away from lithium-ion NMC and looking at chemistries like LTO to see where that can take us in terms of the bigger applications, the heavier duty applications. We haven't particularly set our minds on any new markets other than rail at the moment, but it could take us into bus, trucks, commercial sector. But at the moment, customers are predominantly in the off-highway construction and materials handling. I think that's all.
Thank you very much, Steve. That was excellent. I would like now to invite Lee Jobby of NanoSun. Over to you, Lee.
Just struggling to get the unmute button there. Sorry about the small delay. Hello, everybody. Good afternoon. My name is Lee Jobby. I'm the commercial director for NanoSun. We are working in the hydrogen space, and we've developed the low-cost Pioneer mobile hydrogen refueling station. As a little aside, for the last decade, I've been working for a fuel cell company. And every time, Intelligence Energy based in Loughborough, and every time I tried to sell a fuel cell solution, the customers always said to me, well, where do I get the gas? How do I get hydrogen? How do I get it to my site? So I've joined NanoSun now to help solve that problem. Traditional approaches to hydrogen refueling for vehicles has been fixed refueling stations, fixed filling stations. And the problem with fixed filling stations is there are large CapEx and OpEx projects costing multiple millions of pounds. So when you first put a fixed filling station in, they're going to give poor investment returns. There's a high cost that's a barrier to new vehicle trials and introductory vehicle fleets. And fixed filling stations are no good for mobile fleets, such as we've heard today for like construction sites. So we're NanoSun, we're developing the Pioneer mobile station. If I could have the next slide, please. Okay, so we've reinvented the hydrogen refueling station at NanoSun. It's a combination of volume gas storage, gas transportation, and gas dispensing, all in a single integrated package. And it's actually in a 20-foot ISO container package. The Pioneer enables rapid deployment for small vehicle fleets, and being mobile, it can be easily redeployed. The Pioneer station does not require an onboard compressor. There is no requirement for a compressor at the point of dispensing. The Pioneer operates on a cascade filling solution, which I can talk offline about more if there's no time really now to go into the details. But it means that there is no utilities required at the point of deployment. That means you won't see a Pioneer deployed with some cables trailing to a hidden diesel generator chugging fumes out around the back. We don't need power at the point of dispensing. Well, you still need to get gas for the Pioneer. There's a growing number of hydrogen suppliers in the UK and all around Europe that are able to fill the Pioneer. And for example, ITM Power's Tyseley site will have tube trailer filling capability from the autumn of this year, and that capability can fill the Pioneer as well with gas that then can be deployed on your site to fill vehicles. Onto the next slide, please. So this is my last slide for today. Obviously, time's short today. We have two versions of the product, the P135 and the P145. The P135 is our minimum viable product, and that stores 350 kilograms of hydrogen. And that's going to be demonstrated at various deployments this year. And in fact, over the summer, it's going to be in Germany with our partners, Westfalen. So I'll be sharing more of that in news as that goes on. And at the end of this year, we have the P145 version, which will store 435 kilograms of hydrogen. Both models dispense hydrogen at 350 bar. We're aiming it at the heavy duty vehicle sector. The 135 is our minimum viable product. It's got the non-comms light duty H35 connector. The P145, we're working with Toyota to introduce the SET protocols, which is for those like me, I didn't understand what this is all about until I worked on this project. Some vehicles have communications that need that comms to fill, some don't. The 145 will have the comms, so it can work with any vehicle, whether it's got comms or not. And that's available at the end of this year. Pioneer is a cascade filling solution, so the gas is already pressurized when it's filled into the unit. So because of that, you can use about 50 to 60% of the onboard inventory. You don't lose the rest of it, the pressure drops to the point where you can't make use of it. So this table shows some of the performance, and let's pick up some of the interesting ones. The delivery van, that was modeled on a 7-kilo tank, so a P145 will fill 40 times. The excavator was modeled on a 15 kilogram tank. So I think JCB was in the public domain over the last year with a hydrogen fuel cell digger. So that sort of digger, we could refill 19 times from a P145 and in about 15 minutes per fill, and we could do one after the other after the other. A large bus is typically 20 kilos, and we could do 10 fills of that. For the cars, which are 700 bar vehicles, we could only fill them half full, and that's obviously the first half, and we could do about 95 fills. So that's where we're up to. That's the product. We have built our credibility with key players in every sector of the value chain during our execution of our first station this year. We're working with across the hydrogen space, industrial gases, oil and gas industries, and renewable energy. Our order book for 2022 is starting to fill now. If you want to buy and operate a Pioneer, we've got a project that could buy and operate one, come and see me. However, a lot of our customers don't want to own a Pioneer. They want hydrogen as a service, and we've teamed with Octopus Energy to provide that, with Octopus Hydrogen actually. So from 2022, we'll be offering that service with Octopus Hydrogen. So that's myself, that missing piece in the puzzle between those hydrogen suppliers and those end users and those vehicle applications. Thank you.
Thank you very much, Lee. That was excellent. We would like now to hear from Punch Flybrid. So Tobias, over to you.
Super, thank you very much. Yeah, my name is Tobias Knichel. I'm Managing Director for Punch Flybrid. We are producing flywheel energy storage solutions. Next slide, please. Yeah, so for us, the reason why we're doing what we're doing is that it will become more and more unacceptable to waste energy. And it doesn't really matter where that energy is coming from, is that if that's a diesel engine or an HVO fuel generator or hydrogen machine or even an electric vehicle. It's really about using the energy in these machines as efficiently as possible. And this is where our products can help with. Next slide, please. So for us, generator sets are a key application. They are used often in dynamic applications, and because of that, they waste fuel. So for example, tower cranes or concrete batching plants or polymer piling labs, they have quite some dynamic duty cycles. So on the bottom, the graph, you see a generator operating a tower crane over a 10-hour shift. And you see how the power demand is spiking very frequently. So it goes from a very low power to very high power very often. And if you need to use a generator to power this tower crane, you have to size it for the peak power demand and the transient load. And that means you have to really size it 3 times bigger than what the steady state load is. And that means you run an oversized powertrain that wastes fuel and creates unnecessary CO2 and pollution. Next slide, please. And so what we have done is we have created an energy storage device with a flywheel in it. We call it the Punch Power 200, and that injects energy from the flywheel when it is needed. And the flywheel is very good at injecting energy at high power, doing that almost instantaneously. So we can go from 0 to full power in 30 milliseconds. And we can do that millions of times without degrading. So it works really well for military application, construction industry, for any heavy duty machine that has a long life and a harsh duty cycle in really difficult environments. The flywheel is ideal for this as an energy storage device. And as a result of that, the genset can be sized for the steady state load. So it can be optimized to run at a very narrow operating band. And then the flywheel provides the peak power and the transient load response. So you can really have a primary power source that is quite optimized around a narrow band. And then you use the secondary flywheel energy storage system to deal with your transients and your peak power demands that only occur from time to time. Next slide, please. And so we have demonstrated huge savings on the generators so far. We have enabled downsizing from these generators from between 150 kVA and even up to 400 kVA. That saves up to 25,000 liters of fuel per year per genset on some of the construction sites, with obviously huge CO2 savings as a result. And I think another click, please. So if you combine that with, if you compare that to the savings compared to the emissions from a road car, even fitting a single flywheel system to a single tower crane saves the equivalent of more than 20 road cars over the year. And there are a lot of good opportunities for that. Okay, next slide, please. So it's really about the question of how can flywheels provide a benefit also to your business. We see a big opportunity in hybrid energy storage solutions, where the flywheel can work together with an energy dense battery chemistry, or where the flywheel can load level fuel cell, for example, and that are really good opportunities to use flywheels to their key characteristics and their key strengths. So thank you very much. I think that was the last slide.
Thank you very much. And last but not least, we will be hearing from BMZ Innovation Group. Lucas, over to you.
Yeah, thank you, Nicoletta, and good afternoon, ladies and gentlemen. First of all, sorry, my camera is disabled, so I'll fix it for the next time. Anyway, let me introduce myself, please. Next slide. So my name is Lucas Gazda. I work for BMZ for over 8.5 years. I'm responsible for the UK and Scandinavian region. BMZ is the German company headquartered in Karlstein, where is the production facility. The production facilities are also in Poland, China, United States. It's a 3,000 people company with over 25 years of experience in the lithium-ion batteries manufacturing. Next slide, please. So BMZ over the decade actually developed the e-mobility portfolio and started with the modules for e-cars, then e-buses across the construction machines and towing tractors and the forklifts especially, and many other applications. Next slide, please. So one of the very large projects are for DHL, so starting with 48-volt batteries, currently manufacturing a few thousand batteries per week for the Deutsche Post. Next slide, please. And then develop the batteries for the e-bus sector. These are high voltage batteries, 660 volt. The largest customer is the Solaris, which is, I think, also the largest e-bus manufacturer in Europe currently. So we exclusively deliver the batteries to Solaris. Next slide, please. How do we work? So typically we get the request from the customer. So we have a portfolio of our modules, of our products, and we investigate together with the customer his needs. And then we offer the solution. Then we provide the complete service to our solution. And of course, the other services related like recycling, second life, and so on. Next slide, please. Forklifts, this is one of our key activities. So we have a joint venture with KTN Group, where is the company Linde and Stihl included. We are the exclusive manufacturer for these forklifts, like the battery manufacturer for 48 volt and 80 volt batteries. Next slide, please. We also developed the high voltage system for these boat trailers, autonomous vehicles, 730 volt batteries. Next slide, please. And we work with excavators manufacturers and digger manufacturers, where we also use our modular system, which we apply together with many other customers. Next slide, please. So when I'm talking about the modularity, we use cylindrical cells and prismatic cells, or are NMC, sometimes NCA, but also we use LTO modules. The key advantage of the modular system is that you can use them for many applications. Modify. We have a liquid cooling system, we have a heating system, and then we collect these batteries back from the market, and we are ready to use it like the second life energy storage, which is the key, for instance, for the e-bus operators and the other sectors. And definitely in the energy storage market, I think we will see the trend that more and more will be used only the second life batteries, not the new one. Next slide, please. So that's all from me. Thank you very much for your attention. Please feel free to contact me via email, on the phone. I'm here for you.
Thank you very much, Lucas. Simon, I would like now to invite you to take the Q&A session.
Thank you very much, Nicoletta. So thank you for that. Sorry about that. So we've got several questions as well from the previous chat, which maybe if we just quickly revisit those first. So we've got a question for HS2. I don't know, Andrea, are you still online? Maybe you could answer that. Do you have any comments on the opinion of some in the industry that are developing hydrogen injection systems for internal combustion engines, and this is perpetuating the development of ICEs by the OEMs and attracting investment in batteries and fuel cell technology? So what are your thoughts around that area? Or someone else from HS2?
Hiya, hiya, Simon. It's Neil here. I don't know if I can really answer that question. I mean, we as a client are obviously pushing the agenda for these new solutions. You know, we're not going to be developing those actual solutions. That's for the industry themselves, isn't it? And that's why we go to events like this and work with the likes of KTN, Innovate UK and Bays to let them know what our general demand is. But we obviously rely on those funding streams to steer that development. I think our role as a client is when some of these solutions are available, and you saw that with what Rob and Vic here were saying, once there is a new solution available, excuse me, we can then get it on site as soon as possible, prove it works in a construction environment and try and roll it out. So I think our role really is, once these solutions are available, can we minimize that sort of prototype to proven solution to being deployed across our route, and then getting them into the supply chain and then they can use on other projects.
Yeah, thank you very much for that. Richard, got a quick question for you about standardization. So, and this is, I guess, particularly around hydrogen. So Richard Kemp Harper. So what does the participation look like with the standards community regarding ISO?
So actually, the hydrogen community is really engaged, and it's arguably a lot more consistent in this. I mean, Lee referred to refueling protocols and so on, and that's really consistent. There are still some challenges around aligning vehicles with refueling, but you know, we are working at an international ISO standard level. Things have been moved up from Europe and US to actually international. So I think the industry is really mature in actually the standardization of both the vehicle side and of the refueling side and that interface.
Okay, great. Thank you.
There are, you know, question marks about which consistency about what sort of vehicle pressure you might be working out for hydrogen, but generally heavy vehicles are working at 350 bar for the foreseeable future, and suitable then for Lee's and the NanoSun solution and refueling those things. So there's a lot of consensus around that as well.
Great, thank you very much for that. And maybe bringing Lee there, the 350 bar, do you see that as the dominant pressure for off-highway vehicles?
Yes, we do. 700 bar is when there is real space constraints within the vehicle, and that's why you're seeing it in automotive passenger cars, because they need to get that energy to the smallest space possible. But there's a significant step up in technology and a significant step up in cost to go to 700 bar. That's just not needed on off-highway vehicles. 350 bar for the foreseeable future will be the pressure that they will operate to.
Okay, that's really useful intel. Thank you. So a question for Steve here. Have you looked at military applications? Have you got any use cases around them?
We've had a couple of inquiries. We've had in the last few years, we did have an inquiry for a large energy storage system. I think that was a marine application. And we have had inquiries for autonomous electric vehicles, but we haven't been involved in any projects that I'm aware of so far. In terms of the kind of emerging markets that we've talked about today, we have done a project in agriculture, and that was an autonomous vehicle, and we've just got a new project with quite a big OEM for an autonomous agricultural project, farming project. But again, small machines. They've tended to be small machines with our batteries, so really sub 100 kilowatt hour type machines. Again, starting small, but there's some interest in emerging, but not in defence. When we've looked at it, a lot of the criteria has really necessitated a bespoke development program, and we've not had an inquiry which has justified that yet.
Okay, that's interesting. And you mentioned small vehicles. Are you interested in larger vehicles as well?
I think increasingly so. So we're building a lot of capability at the moment with the Hitachi Rail project. So that will take us into big batteries and also higher voltage batteries for what we've done traditionally. So once we're working in that world, then that does open up bigger vehicles for similar technology, definitely.
Thank you very much. So next question for Nano-san for Lee. So with your solution being a mobile one, are there limitations on the use arising from ambient temperature or noise constraints during discharge and use?
Okay, let's talk noise first. We do not have a compressor on board, and that's the general source of noise at a hydrogen filling station. So Nanosun, with the exception of a few valves, operating solenoid valves, makes hardly any noise or probably no noise. So there's no constraints over noise. Ambient temperature, we don't have power. We don't have a compressor, but we don't also have a refrigeration plant. So we are doing an ambient fill. Now, the Pioneer is designed and certified to TPED, ATEX, and ADR for operation up to 40 degrees Celsius ambient. Now, what we have to do with the Pioneer, the 135 has fixed flow rate control, so the flow into the vehicle is fixed based upon the worst case ambient. The 145, which is the later generation product, has variable control, which can compensate for ambient temperature. So in the hotter ambience, it will just slow the filling down slightly so as not to overheat the tanks of the vehicle that it's dispensing gas into. Sorry, it's a bit of a long-winded answer, but so the answer is no, we don't have a concern for either ambient or noise.
Great, thank you very much. So next I've got a question for Lucas. So do you see signs of increased testing performance requirements from regulators, customers, and insurers? So in the resistance of batteries to, say, thermal events, so runaways. How about for a battery to breach in a particular way to protect the passenger compartment in the event of a thermal runaway of the battery? Do large EV operators evaluate the potential effect of large thermal runaway of their batteries on the building that they are stored or charged in?
So definitely, according to our experience, the part of the BMZ group is the Battery University, which acts a bit independently because of working with our competitors, which test the batteries. Also, famous car makers test the batteries at the Battery University, and they have several tests running and using all these scenarios which you described. So definitely the safety is always on the first place, and we've noticed that there are new regulations, not only on the e-mobility sector, but also the energy sector, like you mentioned, especially homes. And now plenty of homes will be equipped with the batteries. So we need to be part of this. And by second life, this could be also a bit separate story, because I think we need completely new legislation for that.
So new legislation, can you just talk us through that a little bit, what you think?
Yeah, so we need to identify really the key risks for getting the second life batteries from the market, because there are too many manufacturers. Everybody is now the battery expert, I would say, because everybody is seeing this opportunity. But if this wouldn't be regulated some way, like retested these batteries, getting the new certificates for that, just throwing to the market like the second life, I think this is not the best way.
Great, thank you very much. And then Richard, quick question for you about refuse vehicles. So you obviously mentioned the hydraulics, and that's something that's very common with off-highway vehicles. So how did you go about repowering and putting a system in place to deal with the hydraulics on the refuse vehicles?
So the way we do that is relatively simple. It's about adding an electric motor to the hydraulic pump. So you're powering the hydraulic pump with an electric motor rather than a traditional power takeoff from the engine. What that gives you is it actually gives you efficiency benefits for the hydraulics. If you're used to a bin lorry going down the road, you get a big rev of the engine to spin up the motor while it's doing its compaction event and bin lifts and so on. There's a lot of wasted fuel to run like that. With an electric drive of the hydraulics, and this will be true of the electric mini digger and other applications, you've got much finer control. You only run the motor when you need it. It's more efficient to get up the pump up to speed and so on. So you save quite a bit of energy through that, but it's actually relatively simple. I say relative. Our engineers will say no, it's very difficult. But no, it's just a decent engineering job to add the electric motor to the hydraulic pump and drive it that way.
Yeah, you can say it's as simple as you like. So next question for Tobias, please. How do you see, obviously your tech that you presented is slightly different today. How do you see that working with either hydrogen or battery solutions?
Yeah, so the characteristics of a flywheel and a battery are quite different. So the batteries tend to be much better at storing energy for a long period of time and storing more energy than a flywheel. But where the flywheel is very good is at getting the energy in and out of the flywheel very quickly and doing that for millions of times without degrading. And so there are use cases where the flywheel and the battery can work together really well. And we also see that with hydrogen. So my understanding is that the fuel cells, they like to operate at a certain power level, and ramping them up and ramping them down always takes a little bit of time. So adjusting to very dynamic duty cycles can be quite tricky. And so one way to do that is to use a flywheel to do the dynamic load response, and you run the fuel cell at its optimum operating point, peak efficiency point, for as long as possible. And that is quite a nice powertrain combination.
Richard, do you want to add to that?
Well, so that's why we use a battery in our systems, a high power battery, to do that power peaking and management, exactly as you say, Tobias, of that. So you keep the energy as electrical, and then translate it through the battery into an electric drive rather than a conversion into a mechanical load. I mean, I think I have seen hybrids where that works, but I think for our applications, the battery storage, the way we use that for that, yeah, the peaking load works really well.
Okay, thank you. But I guess also you've got stationary applications as well, where that size might not be such an issue, and that might work really well for that. So thank you very much for all of our presenters there and answering the questions. I hope people found that really informative. And I'll hand back now to Nicoletta to close off the webinar.
Thank you very much, Simon. And I will close off with some final comments jointly with Steph. So yes, we just wanted to say to everyone, thank you for joining us, and please do join us at 3:30, where we'll try to tackle all these issues in further detail. We'll also hear from APC on their latest HCV and off-highway roadmap, and then we'll try to identify some solutions. Steph, any final remarks from you?
Just worth remembering that workshop is a different link. So anybody attending that will have received a different link from our colleague Poonam Pool. So just make sure you've got that rather than trying to rejoin on this one. I think really, Nicoletta, it was just to say thank you so much to all our speakers. I think, you know, in quite a short space of time, a quite rushed hour and a half, we've covered a lot of ground with quite a diverse range of people. So thank you so much for that.
Yes, thank you very much. I've counted 16 panelists for our webinar today, so it was a great team effort. Lovely to hear from all the end-use sectors and all the innovators. So we will now draw things to a close and look forward to seeing you at 3:30. Thank you all, and bye.
Thank you.